Till now, we have discussed our field lines and nature, Newton's law of gravitation, and then we have derived our three important parameters which define our gravitational field, and they are field strength, and then again gravitational work done or energy, and then we have derived gravitational potential. So now we'll be discussing the point what happens when some of the celestial or bodies orbit under gravity. So let's take our example of our Earth and the Moon. So now we know that our Moon is orbiting our Earth because of our gravitational field of the Earth. There are actually two forces here. The first force is for the which our Moon is orbiting around the Earth, and while balancing that force, there is another force which actually balances it. That is known as centripetal force. Okay, if the Earth just only attracts the Moon, so what happens? Eventually, the radius of this Moon should decrease, and it should fall or else collide into our Earth. So, but that doesn't happen. What happens? There is another kind of force which usually balances a force of gravity, and that is centripetal force. So, our force of gravity is actually balanced with the force of centripetal force. So now let's equate these two terms, and centripetal force is equation is given by mv square over r, where r is the distance between them. So our gravitational force is usually given by g m1 m2 over r square, and this is given by m2 and v square over r. So this r and r square gets cancelled, m2 and m2 gets cancelled, and now v square is given by gm1 over r. So this is one of the important equations through which we will be deriving a lot of other equations. So now as we got v square is equal to gm1 over r, now we have to know the relationship between our linear velocity and also this angular velocity inside the circular motion. So what is the relationship? That our linear velocity is equal to angular velocity times r. So our angular velocity is usually given by 2 pi over the time period and r. So if we equate this equation to this part, we get to see we get to relate the time period and the radius of the orbits. Okay, so v squared here, so we'll be just multiplying the whole thing. 4 pi square over t square and r square is equal to, let's take this, gm over r. So now let's shift this r to that side and t square to this side. Now we'll see r cube is equal to gm over 4 pi square t square. Now see here, in this equation only r and t are variables, rest of all other parameters are constant. G is a constant, mass of the planet is a constant, and 4 and pi square are also definitely constant. So this is the relation. Here the cube of our radius is directly proportional to the square of the time period of the planet or the satellite. So this is an important relation which we usually get to see in a lot of competitive examinations and also JEE mains. So this is our final equation, and from this part itself we can find out a lot of other things. If they ask to find the relationship between the angular velocity and our time period, or else even our radius, we can, once we know the equations, we can switch to any kind of parameter we want. So this is the end of our gravitational fields topic. Till now, let's summarize what we have discussed till now. So our first topic which I have discussed is our field lines and their nature. And what we will go on, what we got to know that these gravitational fields are always attractive, and these lines will always tend towards the mass. Okay, and the next topic was law of gravitation. So what was the equation of law of gravitation? F is equal to G m1 m2 over r square. And from this part, we got to see that our field strength so what is the equation of this part? As G is equal to capital Gm over r square. Okay. So after this point, we have discussed our work done. And what is the equation of our work done? W is equal to Gm1 m2 over r. After this point, we have discussed our potential, gravitational potential. Okay. And that phi is given as minus capital G m over r. Okay, so these four set of equations are actually, these three set of equations are always derived from this, the first equation, force. And also, just remember this part that these both set of equations means these both parameters depend upon this 1 over r square, and these two equations depend upon 1 over r. Okay, and we have derived this force over this G, and again we got this work done from this force equation, and we got our potential from the work done. So our last set of equation was a relationship between the time period and the radius. So that equation turned out, once we have equated our gravitational force and our centripetal force. So the equation was like r cube, just to write down the topic name, orbiting under gravity. Take it as orbiting. So, and the equation was like r cube is equal to capital Gm over 4 pi square times square of the time period. Okay, so this is the last equation which I have encountered in this chapter. So that's the end for these gravitational fields and their nature and all of the different parameters which I have discussed till now. Thank you.